And hello, welcome everyone to this video. So in this video I want to talk about dial-up and broadband, just to demystify what these are. So just let me start by telling a story. Okay, telling a story. Oh, there's a lot of old stories which I don't really need anymore. Discard, 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 discard. Control W for that. Alright, so let's talk about the story of dial-up. So I guess in the past there were people wondering. Okay, of course you can check out more on this in this video on computer networking courses. The place to look at will be over here, where you talk about wrong place. Yes, broadband connection, dial-up and modems. This is in the part connecting to the internet. You can see the timestamps over here, because I'll leave it in the description, the link to this video. One of the best places if you want to look at all this in detail, but I'll present to you hopefully the quicker version. So the people are wondering, how do you connect two computers? Okay, connect two computers very easy. You can just use one Ethernet cable. Okay, how if you want to connect computers all over the United States? Okay, if you take a look at United States, okay, United States map. Okay, so if you take a look at the map of the United States on Google Maps, you can see it's pretty big. Okay, there are 3 time zones at least, or 3 or 4 time zones, and the West Coast and the East Coast are different by like what, 3 hours between California and New York. Okay, how are you supposed to connect computers all over the United States? Because this is where internet was so-called pioneered. Silicon Valley and all, internet was and all of this was, a lot of development work was done in the US. Okay, so how do you connect a computer in Sacramento and Philadelphia, for example? So are you going to so-called lay Ethernet cable from the east to the west all the way through, or are you going to build a huge radio tower to connect a computer in Sacramento to California, San Francisco to New York, or Los Angeles to New York? May or may not happen. Okay, or may not happen. Why? Because money is involved. It's expensive to lay all this down. So you want to use existing infrastructure. Okay, use existing infrastructure. Infrastructure. Okay, so what infrastructure was available back in the early days? Okay, they actually had telephone. Okay, telephones already conveniently connect phones. You can actually make a call from San Francisco to New York, or you can do telegraph as well. But you see, telephone is the way to go when you talk about cabling. Okay, because the telephone cables were already laid out from San Francisco to New York. You can make a call back in the day. So they're wondering, okay, why not we send our ones and zeros? Okay, why not we use the telephone to send ones and zeros across from computer A in San Francisco to computer B in New York? So this is the idea of dial-up. Okay, what is dial-up? Okay, you literally have we have a modem. Okay, a modem that makes a call. Okay, a modem that actually makes a call. I don't know how to draw this telephone thingy. Yeah, it will literally dial the modem at computer B. Alright, okay, let's make a call. Okay, so the thing about phone calls is that you will need to dial a number first, and after you dial a number, a connection is established where you can both listen and receive. So over here, these are electrical signals that change into audio signals. So these are electrical signals. Okay, so I guess the way you can transmit data across this is I guess if you have a literal phone here, a literal phone maybe a loud noise can be a 1, alright, because you need to transmit ones and zeros across telephone lines. A loud noise can be a 1, and of course a quiet noise can be 0. Okay, a loud noise can be 1 and a quiet noise can be 0. So you can actually transfer your ones and zeros literally using sound. Alright, okay, 101 101. So you can ping, and then you be quiet a while, then you ping again, then you be quiet a while, something like that, you know. Okay, so you literally establish this connection, and what the modem will do. Okay, let's check out. Modem is actually quite interesting. Modem is actually it's called a modulator demodulator. It's actually short for what do you call that? Yeah, modulator demodulator. So what it does is that it takes your Ethernet or your Ethernet signals, it converts them into something that, you know, your phone cable network can understand. Alright, so that a lot, and then of course maybe it converts something like, you know, your ones in the computer to a loud noise, and a soft and no noise will be a 0. So you'll be literally sending pulses of ones and 0 across from one telephone to the other. Then the modem on the other side will convert these audio ones and zeros back into electrical signals, or at least these phone signals. It may not be audible audio, it may or may not. I'm just giving you a rough idea. If you want the more accurate one, just go and read up. Just give you a rough understanding. Okay, you establish a phone call, and then the modem on the other side will say, okay, let me transfer my signals back to computer B. Okay, this is the idea of dial-up. So once your internet connection is done, you can just hang up. Okay, literally like you hang up a phone call. Alright, so okay, dial-up. Of course, there's a problem, right? When you use a dial-up, this is not really good idea, because you cannot use the phone at all. Okay, if you have tried dial-up before, you'll notice that when you use the internet, you cannot use your phone. It's very, very annoying. So how do you use the internet without disrupting your phone services? Okay, so enter broadband. Okay, we still use telephone cable, but don't disrupt telephone transmissions. Okay, so how do you do that? Okay, so the thing we exploit here is with the use of the human audible range. Okay, human audible range is you take a look here, 20 hertz. Okay, 20 hertz to 20 kilohertz. Okay, 20 hertz to 20 kilohertz. Okay, so for an electrical signal, you for the phone range, you can access this frequency, 20 hertz to 20 kilohertz. Any higher, you know, you cannot hear anything anyway, so it doesn't really matter, right? So phone range is 20 hertz to 20 kilohertz. Anything higher, you can in theory use the same cable. Alright, you can use the same phone cable. Okay, so this is maybe modem A, this is modem B, and then this one will actually go to your telephone line as well. Okay, so I'll just draw a very crudely shaped telephone. Okay, so so telephone line. Okay, telephone. So okay, your phone range will be 20 kilohertz to 20 kilohertz. But for your modem to work, maybe you have modem that's going to computer A. Okay, so let me write here modem. Modem A. Modem B. Alright, so for the modem A to communicate with modem B without interfering with the range, we have to use a different set of frequencies. So basically modem A can always talk with modem B if the frequencies are higher. So you need something, greater than 20 kilohertz, right? Greater than 20 kilohertz. So that's the idea. You access signals in there, and this is the basic idea of DSL. Right? What's DSL? You can Google now. Digital subscriber line. This is called DSL. Okay, so DSL, if you look at Cisco, you can look at Wikipedia or Geeks for Geeks. Look at any one of those links, they'll tell you what DSL is. Okay, DSL is basically here to use the same phone line. Okay, I want to use the same phone line, but I'm not going to excuse me. I'm not going to interfere with the human hearing phone range. Okay, so how is it being done? Okay, so how's it being done? If you look at Wikipedia here, okay, your phone line has an audio frequency of 300 to 3400 hertz. All right, this is the commercial bandwidth that you use. Okay, so this is not quite, the 20 kilohertz that we are talking about here. If you hear something at 20 kilohertz, you'll probably be, some people can hear it, some people cannot, but it's a highly irritating high-pitched noise, right? So instead it's 300 hertz to 3400. But anything higher, we can actually use those frequencies to what do you call that? You can use those frequencies to transmit data. So that's the idea. You use different frequencies. Okay. In fact, here you use the frequencies of excuse me, 4 kilohertz to maybe 100 kilohertz. Okay. No, 10 to 100 kilohertz. Oh, I'm so sorry. Yeah, 10 to 100 kilohertz. This is what the DSL does. All right. So this technically is in the hearing range. It's in the hearing range of human beings. So I guess since we have new data, I'm not going to say this is phone range. This is hearing range. This is hearing range. But the phone range doesn't have to cover the whole hearing range. So it's 300 to 3.4 hertz to, okay, not there. I'm already writing here. Here, better. Phone range 300 hertz to 3.4 kilohertz. So I don't have the phone cable doesn't have to cover this entire range of frequencies. Just use 300 to 3.4 kilohertz is enough. So you can actually the phone frequency range. Sorry, yeah, you can use frequencies that are not this range over a phone to transmit data, and this is where broadband actually started. So this is actually called digital subscriber line. Okay, of course there are many other forms of broadband as well. Okay, so we call this coaxial cable broadband. Okay, or cable broadband. This is better. Okay, cable broadband is under this article for cable internet access on Wikipedia. Right. So what's the idea here? Okay, the idea here is very simple. Okay, the idea is very simple. So it's basically the same as DSL, except instead of sharing your phone line connection, you actually share your TV connection. So they use the same thing. TV has a certain frequency range that it uses, but the unused frequency range, you can actually use it with your modem. Okay, you use your modem to do something similar here, to send send cable to send data across the TV cable network. So that's what cable broadband does. Okay, so that's basically it. I'm not going to go through anymore. Last one is quite interesting. Okay, fiber broadband. This is probably the fastest of all. Fiber broadband basically uses well, it kind of breaks the rule. Yeah, fiber broadband kind of breaks the rule of using existing infrastructure. So this is actually building fiber broadband. Use new infrastructure. Okay. Or rather, it's not completely true that we use new infrastructure. Okay, fiber broadband was a more recent kind of I mean, when you have fiber broadband to your home, is a more recent I think a more recent commercial thing. But it's not that we don't use fiber optics before. Fiber optics was used before for phone communications as well. So for example, the first from Wikipedia here, first transatlantic telephone cable to use optical fiber was the TAT-8. It went into operation 1988. So I guess the picture is this. If you have a telephone company that maybe connects to 2,000 homes, right, 2,000 homes, and then it sends to another telephone communication company or another, like, you know, node or something like that, where this is where, you know, 2,000 another maybe 4,000, 5,000, I don't know how many phones are connected. So it provides telephone services. So all the traffic has to go through a certain wire, and usually this wire is fiber optics. This is much later than this is I guess it's still based on a phone network. Okay, I think I'll spell fiber correctly. Fiber. Okay, fiber optics. It's a fiber optic cable that uses fiber optics light signals to send phone communication. So the first place that fiber optics were used was in a telephone, cables. All right. So this is sort of upgrading. Okay. Sort of upgrading the infrastructure. Okay. But then the cables that go home, the cables that are linked to your home, these are not necessarily fiber optics. Okay, your phone cables may still be your regular, like, I don't know, whatever they use for phone, it could be electrical cable. So it's not always fiber optics. But I guess the new part, since it's newer to us on the consumer end, because people get more and more demanding, and they're willing to pay more for high-speed internet. So I guess people have the internet companies have an incentive to sell you fiber broadband services. What is fiber broadband services? Well, by and large, we still use the telephone infrastructure on the internet, but when it comes to the cable to your home, the cable to your home is, instead of a metal cable, it uses fiber optics as well. Okay, and that fiber optics will have to go into sort of a modem, but it's not really a modem, that will convert the fiber optic signals into Ethernet signals or computer signals that your computer can understand. Okay, so this is actually called let me take a look. All right. Okay, so the proper name is called Optical Network Terminal. Okay, you can actually find it, or terminator. This is you can find it under this part in connecting to internet, fiber connections, 4 minutes or 4 hours 5 minutes and 57, or 4 hours 6 minutes thereabout in that video. Okay, so it functions a bit like a modem, but it's not technically a modem. Okay, so yeah, so you can see there are a few different classes of modems. One is dial-up modem, DSL modem, and cable modems. They all do pretty much the same thing, but optical network terminator is to convert light signals into electrical signals, radio frequency signals for the Wi-Fi. So this is what fiber does. Fiber optics, usually they can use it. You can use it to connect big networks together, but in more recent cases, people actually lay dedicated fiber optic cables just for internet, because internet has boomed so much and the demand has gone up, so people are willing to pay more, and therefore new infrastructure is being laid out. Though that technically it's not the whole it's not that the whole network is being rebuilt from scratch. No, that's not what I mean. Okay, so alright, so that's all. It's a good hope it's quite interesting to take a look at all the various broadband and dial-up technologies, so that you can understand roughly how they work. Okay, I'm not going to go into detail. Thanks for watching.